We really had a great time talking with Professor Anthony Duncan in this episode 148 episode of Just in Time. There's no music because it was recorded on Spotify, and Spotify doesn't allow the music to be played. Thanks for your understanding. Little moral of the story, the perspective. This fun little experiment demonstrates two things. A problem is not necessarily solved by new information. The solution often lies in perspective. We can solve a problem by changing the way we look at an already existing reality, at the world, or at ourselves. The solution lies in looking at the object of our attention in a new way. The real voyage of discovery is not about looking for new landscapes, but about having new eyes. Marcel Proust. Very often, the solution lies in the perspective. Have you ever been confronted with a crucial, vital, and sometimes complex problem, seemingly impossible to resolve via conventional analytical or sequential thinking methods? Did you know that science, especially cognitive science, is now taking the question of complex problem resolution via intuitive thinking quite seriously? The latter has proven to be far more effective than any other method in many situations. This is the beginning of the prologue of this great book titled Thinking Like Einstein by Anthony Duncan. And I'd love to go ahead with the interview. I've had the opportunity to make with Anthony Duncan to actually ask him a few questions, and we're going to go over also some excerpts of the book. Literatura, psicoanálisis, proyectos sociales, políticos, humanos, artes, todos los temas son absolutamente bienvenidos en el podcast Just in Time. Desde que empezamos en marzo del 2020, estamos en esta misma idea de continuar caminando mientras grabamos. Ahora agregamos un tema que es la astrología. No existen temas superiores, temas inferiores, y a veces tenemos invitados que son presentes, que están presentes hablando, o bien simplemente que están con una presencia simbólica muy importante. Bienvenido al podcast Just in Time. Hi.
Hello.
Hi, Anthony. Good afternoon for you. Here it's good morning.
Yeah.
How are you?
Yeah, I'm fine. Here it's more like the evening.
It's the evening. Yeah, good evening then.
Yeah,
I was wondering if we were going to do this episode through telepathy, but then I realized we're talking now. Yeah, I didn't know you had to create a Spotify account for that, but it's great to learn things every day. Actually, this is what we're going to talk about: how to learn differently, how to live differently according to intuition and the full conscious of the body and mindfulness. And I want to say that I'm really glad to be talking to you today. It's quite awkward because we could speak French, on pourrait parler français, but we decided to speak English, which is quite fun, I think. And I must tell you, I was reading your book two Sundays ago, and I really was so happy to be reading your book. I knew you had published it a while ago. I hadn't had time to read it beforehand. I read it in English and I read it in French too. I must say it's an amazing book, and I think many people will be very interested to understand how you understood Einstein and what you took from your study of this genius, and how we can benefit from what you call the anti-method, right, of Einstein. His very unconventional way to approach life and approach problems. So thank you very much, Anthony, to be here today with me and talking to me.
Well, thank you. Thank you, Ellen.
Well, I'd like me if you would introduce yourself, how would you do it in a very non-conventional way? Where are you? What do you do? Why are you talking to me about Einstein? Why Einstein for you?
Well, first of all, my name is Anthony Duncan. I'm a teacher at the professor at the University of Rouen, and
In France, right?
in France, and I fell upon Einstein very well when I was quite young, but I never really understood how should I say, his way of thinking and so on. It's more through the science that I discovered Einstein. And until I read his article in 1905, which was his first article on the theory of relativité restreinte, which would be the first theory of relativity. And so it kind of struck me that his way of thinking and writing articles were a bit different from what I was used to, because as a scientist, I generally I go through a lot of article reading and so on, and his way of writing articles is totally different. His way of thinking is totally different from what I was used to. And also he talks a lot about intuition. He's one of the rare scientists who actually talks and is not afraid to mention the word intuition many times in his life, all through his life. And he sort of even said himself that most of what he owes to humanity is through his intuition. Like he mainly gives a lot of credit to his intuitions. And so that is sort of struck me, because the intuition, generally when we think of it in a very metaphorical or mystical way, and his until I realized that he has a certain approach that is quite methodical, but he wasn't the only one to use intuitions, but he's one of the rare scientists who sort of mentions the intuitive approach a lot in his work. So and then also how should I say, he since he's one of the how should I say, he's one of the few scientists who sort of was able to sort of touch a lot of many different thematics, and so I guess that also was one of the source of his intuitions, the fact that he was what I call the voyage transthématique, where he sort of goes through. He very, very early on was interested in many subjects already in science, which is a very specialized field, but he was sort of already interested in many different fields, and he created many different fields as well because of his interest. But also this interest in many different fields allowed him to have many ideas and to sort of transfer certain methods and ideas into a new field and see how they'd work out, and it would sort of bring him to sort of new discoveries and new intuitions and so on. And so the key, I guess his key, that was sort of his key power, was sort of that ability to be able to understand many different fields. And I think that is probably one of the first issue towards the first, how should I say, la première piste, the first step towards intuition, is to sort of have an open mind and try to sort of, how should I say, a curiosity first of all, and explore, have no fear of exploring and crossing thematic barriers, and being interested in many subjects, and so on. Not just like for him, he's in science, but he also interested himself out of the boundaries of science and economics and philosophy and so on. So very young, he read many books in many different fields, whether it's in philosophy, politics, Marx, and so on. And sociology and so on. So he's very well bred. Yes, like a wide, broad,
Hmm.
knowledge person, and so I think that's very important as well. In
It is.
mhm,
Yes,
yeah,
actually, that's what I found, and I find fascinating about him, because it's quite the opposite of what the education system tries
exactly.
to
Yeah,
teach us. I
exactly.
remember how many times I've been told that I wasn't concentrating enough on one subject, and I was thinking, why should we restrain ourselves
Hmm.
to just one subject? So I think it was quite lucky for him not to be successful at school, and we could start today with Einstein at school.
Exactly.
I think he was lucky not to be that successful, because otherwise maybe he could have lost his curiosity. How was he as a child? First of all, what kind of child was he? In this podcast, you will learn many things about his childhood through you, Anthony. But also you'll be able to listen to my voice reading some excerpts of your book
Okay.
in English, because that's what I love reading, and I love reading out loud, and that's what I do sometimes in this podcast. So, how was he as a child,
Well,
Einstein?
first, it's interesting that you mentioned exactly what you just mentioned, because as a child he had a very slow start, and he after actually when he became an adult and he became a well-known person for his discoveries, he 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 used to joke a lot about it's about the fact that he had a slow start, and he said it's probably because I had a slow start that I ended up well, because that slow
Hmm.
start allowed me to sort of explore um, many things and many subjects, and to explore deeply many subjects, and so
Hmm.
in that by that by how said that approach, that's what allowed him to sort of first of all, like, come to certain intuitions, as I mentioned. But to get back
Yeah.
to his childhood, he was very already at when he was born. He As a very young child, when he was 4 years old, his parents um, were very worried about him, because they thought he had some kind of mental or intellectual disorder, because they thought he
Hmm.
was slow,
Hmm.
much too abnormally slow. Um, his nan used to call him the dummy, because he was very slow, and it took a lot of time for him to talk. Even the
Yeah.
first words, he didn't utter them until he was like 4. Um, he often and when he first finally started to speak, he would sort of repeat phrases in a sort of repetitive manner, which
Hmm.
is called today. It's There's a word for that. It's called ecophrasia, and
Yeah.
so people thought he was like mental defective, his
Amazing.
short surroundings, and so echolalia, interestingly, is sort of related to ASD,
Hmm.
autism
Hmm.
syndrome disorders, but it may have not been that. I mean, if it's nothing, we don't have any evidence to support that, but it's generally
Hmm.
associated with that. And then when he finally um, came to about 5 years old.
Yeah.
Um, his um, his father, he fell sick in bed, and his father offered him a compass, and that
Hmm.
was the around that he was fascinated by the compass. He'd spend hours looking at that, and he would say that is the first his this little object in which he focused was his sort of the source of his first intuition
That's
as a
so
child.
amazing. This gift his father gives him at that time. It's so symbolic, right? It's
Yeah.
so, it carries so much symbolical meaning. In a way, in
Yes.
psychoanalysis, we know, the law of the father, the father's law is about. It's very important. This act of giving
Hmm.
of this present. I think many things could be told about that. It
Hmm.
might have changed his destiny. What do you think?
Yes, definitely. I agree
Hmm.
with that. Yeah.
Was he
Um,
very protected by his mother? How was
that's an
he?
interesting point. He doesn't mention much about his mother, not like Nietzsche would, for instance. No, he doesn't
Yeah.
mention much his mother. No, um,
Hmm.
I think.
Where have you read Einstein? What are your sources, Anthony, about
Well,
his mentions?
one of my main sources is the Codable Einstein. So,
Hmm.
it's sort of the most I would say a complete source on that. So it's the author's Alice Calipris.
Hmm.
So it's called the Codable Einstein. But I also read many of his own books. Like he wrote a lot on many subjects, whether it's on his situation in the States, on the racism problem, on the black problem in the States. He wrote a lot on war and peace.
Hmm.
Einstein himself wrote a lot on those things. And also, he wrote a lot on his own explorations in science. And so,
Yeah. How was
his,
he as a writer? How do you?
he was quite didactic.
Hmm.
He sort of was able to sort of explain simply how should I say complex concepts. Sorry. So
Yeah. Yeah.
he was known afterwards to be quite a good professor, although he had very few students who would come to his courses because his courses were sort of a more focused sort of type of audience. But those who
Hmm.
sort of assisted his courses say that he was a very good educator, very good. He would transmit complex ideas in a very simple and clear,
Hmm.
easy to understand fashion.
Yeah, that's actually what I found in your book too. You managed to explain very simple way, and it's quite easy to understand, which really,
Mm-hmm.
really is amazing.
Thank
And
you.
so, before going back to his childhood, which book would you recommend if the people who if people who listen to us at that moment would like to start reading Einstein, would it be The World as I See It? Which book
Well,
would you recommend reading?
the world of it, as I see it, is more like for it's for his adult years. He talks a lot about it. He talks a bit, sorry, about his childhood, but um, it's very hard to find books on his childhood. He doesn't like. He will mention briefly. And
Mhm.
I do believe maybe because he lived in a time where people focused less on the child than on the adult.
That's true.
Not
Sure.
like today where children are more important. So it was a different time. Yeah. Hmm.
Yeah. Okay.
Yeah.
Okay. So his dad gives him this compass, and then something happens, right?
Yes, he sees like he sort of like plays around. He turns the compass in many directions, and every time he changes it or he sort of
Hmm.
perturbé, where he sort of like shakes it or turns it. It always
Yeah.
the needles. He's fascinated by the fact that the needle always comes in the same direction,
Mhm.
points in the same direction, even if it's although it's not there's no how should I say physical action, apparent physical action on it. So as a
Yeah.
child, he sort of says like he was sort of like deeply moved by the fact that there was deeper forces in the universe that were invisible forces that sort of governed the laws of the universe. And so that
Invisible
sort of
forces. Yeah.
that's
Hmm.
right, they govern the laws of the universe. And that's so he was always so that was that deeply that was his a very profound like epiphanic experience. And he said, well, like that was the first time where he said to himself, I'm going to give my life, or it will be my mission in life to explore uh, precisely these deeply hidden laws of the universe,
So he
especially
understands
these
very
invisible forces. Uh-huh.
okay. He understands
Yeah.
very early what his life
Right,
mission is.
exactly.
You think so?
Yes,
Yeah.
exactly.
Hmm.
He at least, and then he changes as he grew a bit older. He changed a bit his track where he wanted to become a rabbi, and
Oh.
but then he sort of gave up on that once he sort of realized that everything that was written, what he considered that everything that was written in the Bible couldn't be true. So that's when he changed his approach. But he often used to say, I'm how should I say, I believe in the God of Spinoza.
Mm-hmm.
And so he did, in a certain way, I would say, contemplate science as sort of almost like a religious activity, I would say.
Yeah. Okay.
And he really even say himself, I'm deeply religious, even though I'm not a believer. I'm a deeply religious non-believer, in the sense where he didn't believe in traditional religion, but he did believe in some kind of spirit, that sort of like infinitely greater than the spirit of man, which governed the laws, which constituted the laws of the universe, and so he wasn't really as religious like Einstein, like Newton was, but he sort of had this sense of awe, and he was religious in the sense where he always kept that sort of sense of awe in front of the wonders of the universe, a bit like a child when he was a child in front of his compass.
Exactly. Amazing. And I understand he was, would you say he had a happy childhood?
Well, actually, not well. In a way, in his family, yes, it was sort of like um, how should I say, peaceful environment in his family and so on. So he had the love, I would say, of his parents. He had a little sister.
Yeah.
Everything was fine. He was more like outside, he would say, because he grew up in Germany. So he says, like, when he was a child, he used to suffer from the bullying at school.
Yeah, sure. I guess.
Because he was different, a bit like children who are a bit different here sort of get bullied, here, I mean, in our time. And he said he was sort of, even though he was impermeable to the attacks, he would
Was he?
nevertheless, from the other children, he said that, like, it nevertheless gave and distilled in him this deep sense of alienation. So he felt apart, not because he felt superior to others. On the contrary, he felt not really inferior, but he felt different. He already felt different very as a child, because of the bullying, because of the treatment that other children would give him. So he was quite a lonely child in that way. But but on the same time, he was not, how should I say, he was someone who enjoyed being alone, because it would give him a lot of time to contemplate. And so yeah, contemplation and observation is a very, very key factor in Einstein, in Einstein's life, and I believe in his intuitions as well.
Yes, he was lucky to be able to get bored, because I mean, today's children, they don't know what boredom is anymore. That's a
Exactly.
big problem.
Exactly.
That's a huge problem. And how
Yes.
would you explain that he felt good at home with his parents, despite his parents were very worried? You said they were worried that her son, I mean, their
Right,
son
when he
could
was
be.
when he was quite young, when he was 4 or 5, and then finally he moved out of that, and like he slowly started going to, when he grew older, when it's like 13, 14. Yeah, he did actually have a tutor, a professor. There was a student in medicine who came to his house, and sort of like, they saw that he was already interested in geometry and so on, even though he was a calm, sort of like a bit remote child. But so they saw that he had this intellectual curiosity. So they gave him a tutor, like a professor who was actually, I think, a student who was in medicine, who so would come and talk to him about mathematics, geometry, and so on. And so that's when he started really having his first love affair, in entre guillemets, in quotation, with science. And so
Okay.
that's also this interaction with this student in medicine who was very cultured in science. This sort of led him towards science, and he gave up on the rabbi story, the desire to become a rabbi, because that's when he realized that actually science was not very compatible. Well, the religious writings were not compatible with the reality of the world and with the laws of the universe. So that was his first sort of like desire to sort of go back to go further and explore further the world of science. Yeah.
Okay, so we're going to if you allow me to read an excerpt of the first part of your book, which is dealing with his childhood. We can listen to this part, this excerpt, and then we come back to keep on talking about this wonderful genius and his way of thinking. So I'll see you in a few minutes.
Okay.
I'll hear you in a few minutes.
Okay.
All right. Thank you.
Thank you. Bye-bye.
Nevertheless, an unexpected event marked his childhood. His father gave him a modest gift that he found magical, a compass. This innocuous object triggered an unsuspected sensory experience in him. For him, it was like a half-open door to the deep mysteries of the universe. The movement of the needle fascinated him. His gaze was magnetized. Whatever the orientation he gave to his little compass, it seemed tirelessly to return to its original position, as if bewitched by a mysterious force. He was seized by a sudden sense of wonder. An undescribable feeling grew inside him. He would describe it later as essential in his life. It is entirely possible that behind the perception of our senses, unsuspected worlds are hidden, of which we are unaware, he stated. Einstein at school. He was 16 years old at the time. He didn't know what to do with his life. He was struck by his school experience and later described his vision of an ideal teacher, which he missed so much, as follows. His essential role is to awaken the joy of working and getting to know people.
So we listened to the excerpt of your book on childhood, and what happened when he was 16 and when he was older and he had to make a few decisions about school, about his future. Did he know what he wanted in life?
Well, at first he had a lot of questioning. He first of all, the education system, he was born in Germany, so the education system there was quite military style. So he mentioned a lot that he did not enjoy school. So what happened
That's
is,
important, isn't it?
yes, when he was 16, his parents moved to Italy with his little sister, and he was left there at high school, and he actually failed the equivalent of the baccalaureate in France, which would be his last year of high school.
He failed it.
So he actually failed it, yeah. And so then he sort of moved on and joined his family in Italy, and there he enjoyed much more of the sort of the free spirit that reigned, as he mentioned in Italy at the time. So he went to school there.
Where? Do you know where? I don't remember where he was.
It was in a small city of. It's sort of, I have a blackout now.
Yeah, don't worry. We're going to find that later on.
Yeah.
I love Italy. That's why I'm asking.
That's right. And it was a small city in Italy, and if my memory's right. And he basically started finding pleasure, reprendre le goût à la vie. So he started enjoying life more. And he
wasn't he in Lombardy?
Maybe, yeah, it's quite possible. I'd have to check that out. Yeah.
Yes.
It's a long time I wrote this book. That's why.
I know. So il duce far niente saved him.
That's right. Exactly. There's the kind weather, the clement weather as well. Yeah. And the sun. And
that's interesting, isn't it?
Yeah, but he'd often say that the best professors he had were those who sort of like, for him, the best professor. His ideal professor was the professor who sort of like instilled the joy of learning, rather than and instilled the joy of learning, but also the joy of thinking and learning how to think, rather than learning a bunch of equations, a great number of equations, or the connaissance of knowledge. He was sort of more attracted to his professors who he envisioned more the role of a professor as someone who really instilled the pleasure and the capability, the capacity to think, and that was more important, and to also develop your imagination. So all those things are things that weren't he difficultly found in his days, at least in the schools where he went. He did find that with certain professors, and where he was in Italy, but it was probably also part of his the fact that he felt better, and under the Italian sun, that sort of gave him back a bit of pleasure. But he was often en proie. How do you say that in English? He would often be, how should I say,
assaulted or taken.
Taken back by doubts. I wouldn't say depression, but doubts, profound doubts on his value, on why he was here.
On life, on Earth. You mean why he was alive?
Why he was on Earth, and he once wrote a letter to his father. It was a bit later on when he got a bit older.
I remember that you mentioned that in the book.
Where he said it would have been better if I was never born. So
amazing.
It's far from the idea of the genius, of the happy, how should I say, the self-assured genius. It's like we're far from that, so.
Well, I mean, when you think about it, what would have happened if his family hadn't moved to Italy?
Yeah, it's interesting, how things differ. Evans sort of like. There's a certain randomness to all this, I would say. The Evans. Apparently his father was owned a company, and it was a period of time where, in the history of science, where technology, where electricity was starting to play a very important role, the electromagnetic phenomenon, and so on. So he had a company that was sort of like dealt with that new field, but his father was not a good businessman, so that's why they moved to Italy to sort of. So he gave up the company in Germany and he moved to Italy to join his brother, who also had a company in that field. So, as a child, he was already exposed to the electromagnetic. La matière, the subject was very, how should I say, it's a subject that's very important in his work. He was fascinated by Maxwell, and the equations of Maxwell are the equations that sort of describe the four laws of electromagnetism. So, so he was sort of like already exposed to all that. It's not like he came out from nowhere. So his
Of course. Yes,
so
he had a very
surroundings
good
play a role as
environment,
well.
right?
Yeah.
Yes, of
Excuse me,
course.
sorry.
He had a very good environment,
He had a
right?
good environment, exactly.
Yeah. Could you remind us what are the four electromagnetic laws, please, Anthony?
Yes. So the first law deals with the law of Gauss, which is more about the static electricity. Static electricity. It's a bit like when you rub something. If you rub a bar of an insulator against your wool, and you put a little piece of paper and you tear a little piece of paper, and you sort of charge by rubbing. You charge the ruler, an insulator, a plastic ruler, for instance, and you rub it against the. Well,
we all
it
did
will
that at
become
school, right?
electronized. It will accumulate electric charges. And you will be able to pick up the little pieces of paper with it by electrostatic attraction. So that's sort of the first law, the laws of the electric attraction. There's also the law of magnetism. The second law basically mentions that a magnet always has two poles. You cannot have one magnet with only one pole. So even if you have a magnet and you cut it in two, you'll always have you have north and south pole. If you cut the magnet in two, you'll always have the two magnets will have a north and south pole, and if you do that an infinite number of times, you'll always have until it's something very small, you'll always have north and south pole. So that's the second law that sort of explains why that and describes that. The third law is about has more to do about the fact that when a wire there's electric current in a copper wire, for instance. Well, it will create an electric field, and the opposite is true as well. It will create a magnetic field. So a circulating electric current in its surroundings will create a magnetic field, and the opposite is true as well. If you have a moving magnet in a coil, for instance, and you move the magnet in the vicinity of the coil, of a copper coil, for instance, you will have current, electric current that will be produced in that coil. So that's the sort of basically the third. And the fourth law sort of is more the law about light. I mean, in that fourth law, you have the equation in the fourth law equation, you have C, which is the celerity or the speed of light, and so that sort of law explains basically how light propagates itself. It's sort of by this alternating electric. Electric field creates a magnetic field, and on the opposite, the alternating magnetic field creates an alternating electric field. So that's what light is basically. It's sort of a propagation of oscillating field between the electric and the magnetic fields, and that's very important to that law because Einstein will use it as a buttress or the support for his first theory of relativity, where he will try to understand the motion of light with respect to moving objects, and so that will be his first. That will lead him to his first intuition on the first law of relativity.
Okay, thanks a lot for that. So he was very aware of that. He was very versed in these four laws very early, very young, right?
He would exactly. That's very, very exact. It brings me back to to your question about how, as when he was 16, it's true that he used to read a lot of books on electromagnetism, on geometry, which will play a big role in his life, in his theory of, in his general theory of relativity, so geometry, and a lot on philosophy. So, and in particular, these are the philosophers of science that would sort of like question themselves on, how should I say, on, we'd call it philosophie des sciences, philosophy of science, where you try to understand, like one of the questions he would ask himself was, is it possible to sort of like, that human knowledge may understand and comprehend the whole universe? Is it possible? Is there limitations on what humans can know by the fact that they're finite beings? And
Sure.
you know, we live in a sort of like, at the time we thought the universe was infinite, but there's infinite ignorance that we, even now, of course, Einstein would agree, we have an infinite ignorance on the laws of the universe, even if we know a lot. And every time we push further to sort of know more, there's always new questions that arise, and so on and so on. So that's the evolution of science. But
Yes, I love that. I
yeah,
love that quote. We have an infinite ignorance on the
that's
laws of
right.
the universe. Yes, and you did mention he didn't have the exam. He didn't make it. And then, how did he do? What was his strategy to be able to keep on studying if he didn't make it?
Yeah. Well, he at distance he passed. It's an exam where you he was able to sort of like take a secondary track. It's called une passerelle, you call it in French, where a secondary track where he was able to sort of get an equivalent an equivalent level of the baccalaureate of that examination, and then he was able to go to the university, which was l'école de Zurich de Polytechnique.
Okay, yeah. Okay, so that's when he got into the Swiss Federal Institute of Technology because of,
Right.
I think he had a superb mathematics and physics core, right?
That's right. He's all the other.
Yeah.
It's interesting because the courses where he did not do well, which he did not enjoy. Sorry, he did not do so well. But he wasn't. To sort of destroy the myth that he was a bad student, it's not totally true. It's just that he was far more better in the subjects that he enjoyed. But nevertheless, which brings me to his professor of Greek, who which is very funny because his name is Professor Degenhardt, who said, who told him at the time when he was like, before he was still the young high school student, Professor Degenhardt told him that he would do nothing of his life. He was a total loser.
That's amazing. You know,
It's very funny.
somehow, yeah, maybe. I mean, of course,
There's
it's
many people
terrible.
who relate to these stories, you know, who in many, not only in science but in many fields of human activity, where their professor would say, "Well, you're good for nothing," and then they end up being, top actors or
Exactly.
or
Actually,
top
you wonder.
psychoanalysts or so on.
Yeah, of course, but you wonder
Very
maybe if
amusing.
these specific sentence maybe had an effect, right, on people who've been
Yes. Maybe it pushes them
receiving. Yeah,
forward. Actually,
it
it may
it
crush
might be.
certain people, but then it may, other people it may sort of like be like, "I'm going to show you," type of
Like a revenge.
sort of vindication, revenge. Yeah, vindication. Yeah.
Yes,
But I
yes,
do think
probably.
Einstein did have a bit of that. Like, from his writings, you get the feeling that there is sort of like, "I'm going to show you who I am" type of thing. Like once he started to sort of regain confidence and so on, it was like, it's a bit like the runner in the race is sort of like a slow starter, and then he sort of builds up speed, and so he was sort of like not competitive against other people, but competitive with himself. He expected a lot from himself. Once he started becoming a bit bit more mature, and he how should I say, he worked a lot. That's also important in intuition. Like,
Yes, you do mention that.
often,
That's so important.
yeah, because often you get the idea that intuition just falls, from the sky. No, no, no. Someone who worked really, really hard. So, and that's when
Yes.
his intuitions came after the hard work.
Yes, he didn't. He never stopped studying and working, right?
Exactly.
He
And
really, I think he really believed in excellence
yes,
as a concept.
exactly.
He
Exactly.
studied all the time, right? He worked all
Y-
the time. I think you do
Yes.
mention. We will mention that later on when we speak about his adult life. But you do mention the kind of agreement he had with his wife. But we can talk about that later
Yeah.
on.
But
We're going
he
to
would also
listen to,
mention le
yeah.
bien, le
Tell
beau,
me.
le vrai. That's right. Le bien, le beau,
Le
le
bien, le
vrai.
beau, le vrai.
That's
Yes.
what his that's what his ideals were.
Yes,
So
yes.
the
Maybe for
yeah
people who don't speak French,
the
le bien, le beau, le
the
vrai.
the good, yeah, the good, the beautiful, the true.
Yes,
So yeah, the aesthetics, the hard work, and truth. Yeah, and so so basically, yeah, there's just to sum up that idea of excellence.
hmm
Is very, very
yes,
important. And also work was fun. It was like a game. That's another thing. It's like he worked hard, but it was a game for him. It was
of
like a
course.
child
He,
plays a
he he
game.
he took pleasure in that.
It's a pleasure, and
There
that's
was
why it was
pleasure.
not. It was easy. It was. I mean, it was not a une corvée. It was not. It was
Yes,
hard work, but it was not unpleasant or dull to him. Yeah, and
yes. I think
so and
that's
I think
so
that's
important.
important too, because in the education system, I find we should be more into that. So like even as a researcher, like take fun in like what we do. But how should I say? I think it's more the education system, and I would say the system at large that produces knowledge is still in that old mindset that you have to suffer, or you have
Hmm
to sort of not enjoy what you're doing. It has to be harsh and unpleasant, and how should I say? It's like some kind of how should I say, like a missionary
Yeah, like
sacerdoce,
yes,
sacerdoce,
you should be
instead of it,
punished, right?
yeah, instead, and life the
Punishment.
same could be the same, like let's just enjoy, like let's enjoy this discovering, let's enjoy working, let's enjoy um, uh, discovering knowledge, creating new knowledge, but yeah, doing it in a fun way. And I think that's why sort of intuition is linked to the childlike side. That's where I wanted to get to. It's
Yeah.
sort of linked to the childlike side, and so you got that sort of like that sense of awe, of
hmm
enjoyment as a child, with the playfulness, but that you'd have as a child. But you have this sort of the analytical power of an adult, and sort of that's what I think made his discoveries powerful, is because he had those both things, and it was not just the analytical cold side of things that like and I think that's what gave him a lot of, that's what allowed him to sort of make these great discoveries.
Exactly. It was the pleasure, and studying for him was not a chore,
That's
right?
right, a chore. That's the word. I was looking for the word. Une corvée.
Yes,
That's
it's
right, a
a
chore.
chore. I mean,
Hmm.
this is the problem because we still keep on placing education as if it was a chore. I mean, it
That's
should
right.
be so happy. It's so
That's right.
amazing to learn things.
That's right.
But very often, the education system kills the
Exactly.
curiosity. It kills the
Ex-
pleasure that it is actually very inherent to any child. Any
exactly.
child wants to learn. I mean, we know that when you're a child, you keep on asking why, and why is it like that, and why it's so
Hmm.
natural. It's very,
Hmm.
very natural to be curious. But
Exactly.
very
Hmm.
often the system kills that. Okay.
I would agree.
Yeah, thank you. I suggest we listen to some of your excerpt about
Sure.
his student life. I mean,
Okay.
these are two excerpts, one about his student life, and the other one about his situation at school. First is at school, and then as a student, and then we are coming back to talk about his adult life and his first intuition.
Okay.
So see you in a bit.
Sounds good. Mm-hmm.
Bye-bye.
Bye-bye.
Student Einstein. As a student, he skipped most of his lectures except for a few that he was passionate about. Nevertheless, he worked assiduously on subjects not yet taught in his curriculum, notably Maxwell's electromagnetism and the thought of great philosophers such as Spinoza. He owed his salvation to a studious friend who took notes for him. Needless to say, Albert did not have a good reputation with his teachers. They saw in him nothing special. In fact, none of them offered him a job after he graduated from university. So began a long period of wandering and uncertainty for him. Alone and dejected, he began to resign himself to the idea that he would probably do nothing good with his life. This feeling was shared by his father. At this point in his life, he wrote in a desperate letter to his parents, "I wish I had never been born." He sent several applications here and there in the hope that an employer would want him. Then one day, his horizon became clearer. He had just been hired at the Patent Institute of Bern. He was conscientious in his work, a striking feature in him that contrasted with the traditional image of the dunce that is all too often conveyed. But very quickly he got bored, so he started daydreaming. Certain ideas had captured his imagination since the age of 16, notably those about the fascinating late nature of light. His daydreams and reflections led to 3 radically new concepts that were to forever change our vision of the world and our future. His first intuition. On September 26, 1905, Albert Einstein was 26 years old. He had just published his first article in a scientific journal entitled Annals of Physics. At first, it went unnoticed, but many years later, its contents were to completely overturn the game table of our conception of the world, time, and the universe. But before exploring his genius idea and intuition, it is important to recognize here the merit of the journal and its director, Max Planck, who gave this young man, still unknown to all and not affiliated to any recognized academic institution, his chance. To add details to the picture, Einstein had never worked on a laboratory bench, and he was not supported by any great professor or academic authority. The journal accepted his article on the basis of his sound and new ideas. This would be hard to imagine today. In any case, his article dealt with his reflections on a paradox. He tried to solve it. His approach was as simple as it was confusing. How did he achieve it? By playing with a coil and a magnet, and through his intuition.
So what was his first intuition, Anthony?
Yes. So his first intuition arrived in 1905. So that was the year of his publication on the first theory of relativity. So maybe I probably need to give a little context of this, what the knowledge at the time and why it was a breakthrough.
Yeah, that'd be great. Thank you.
Yeah. So basically, there was a lot of questioning about the nature of time, the nature of how this light travels, and the nature of space. space and time were the big questioning. So, and one of the questions was like light is what was how there's two main frameworks. There's like the absolute framework of time and space that was sort of given by Newton. And so in this reference, absolute reference of time and space, everything would follow the laws of Galileo. So, for instance, if you're in a train moving at constant speed, if you let an object fall, it will fall exactly. For you in the train, if you're moving at constant speed, the object will fall exactly the same way at the exact speeds at different times. Then if you did the same thing on the platform of a trainway station, and you did the same experiments, the ball will fall according to the same laws. Another example: if you're how should I say, you're on a let's imagine you're on the back of a truck which is moving at a certain speed, let's say 60 kilometers per second, and you throw a ball in the opposite direction of the movement of the truck. Well, the ball will follow a speed that is lower than 60 kilometers per second. So basically, there's the law of addition of speeds that will play. Basically, if you're moving forward and you throw the ball at, let's say, 5 kilometers per second, the ball will be moving at 5 kilometers per second plus the speed at which you were moving forward. So that's called the law of addition of speeds. So many people thought light traveled the same way. That imagine if you're in a spaceship and you were moving, let's say, at 25% of the speed of light, and you shot a ray of light. At the time, people thought that the ray of light would go at the speed of 1.25 times the speed of light. So they thought the speed of light would obey to the same laws as a particle, for instance, an object. So the same laws of addition of speeds of Galileo. So this is very important. Like this concept that if you're moving, the common knowledge was that the speed of light would depend on the speed of the moving source of light. Do you understand? That's very important. So, for instance, like the speed of light is known to be at rest. For instance, the speed of light is known to be 300,000 kilometers per second. So it was thought at the time that, just for the example with the truck I gave you, that if you were on a spaceship and you're moving, say at 300,000 kilometers per second, if you could, and you shot a ray of light, well, to an observer that would be at rest, he would see the light moving at 600,000 kilometers per second, because the speed of light would be the addition of the speed of light from the spaceship. Would be the law of addition would say that, well, it would be the speed of the moving ship plus the speed of the light, so it would be double the speed of the light. So that's the way people sort of viewed the scenario of light, how light moved. So light is at the key of his first relativity, of Einstein's relativity, because theory, because he already at the age of 16, he was obsessed with the idea about how fast light moves, and what would happen if he managed to run and to attain the speed of light. In other words, if he was able to see the end of a ray of light, for instance, what would you see? Like, imagine you could run at 300,000 kilometers per second as fast as the light. Well, you would basically be able to run like a runner on the track, or two runners on the same track, the same one beside each other. You would be able to see the end of the ray of light, right? If you can move as fast as the speed of light. So what he knew from the equations of Maxwell is that the speed of light oscillates, right? It's a wave, and so it's a wave that that occurs in time and in space. So what he was basically observing is that if he managed to sort of travel at the speed of light and arrive at the end of the beam, he would basically see like a wave that would be frozen in space, but would be still moving, fluctuating in time, or the opposite, that would be frozen in time, but still it would, but possibly moving in space, oscillating in space. So that's sort of in either case that contradicted the laws of the fourth law of Maxwell. So he said he said, so that was sort of like his first problem. He said there was something wrong with the way we envision the speed of the way light travels. That's the first thing.
Okay.
The second observation is that the idea of the absolute rest. So something that there would be an absolute rest with respect to an absolute frame of reference, that sort of bothered him. And the example, this is where the little experiment of the wire, the copper wire and the magnet comes into place.
You do describe it very clearly.
Right. So if you have a magnet generally and you put it, it's a common experiment, and you put it you make it move at a constant speed in the center of the coil.
Yeah.
Theoretically, you'll have an induced current within that coil. So physicists would say you have what is called an induced electrical field. So the way most people saw that experiment was that if you move the magnet and the magnet is moving relative to the coil, well, the coil is at rest, but the magnet is moving, and you would see the creation of electrical field in the copper wire, and that would give in turn an electric current, and the light bulb would light up, right? If you had the light bulb connected at the two tips of the wire. But if you look from the perspective of the coil, and the magnet is at rest, if you move the coil, well, theoretically at the time, the description that the physicist had at the time was totally different. When you move the coil, in fact, what actually happens is the Lorentz force is exerted on the electrons within the coil copper, and this force is due to the fact that you have a moving magnet, and so it's the Lorentz force. And what is important to remember is that for the same phenomena, you had two different explanations. So that bothered Einstein a lot. So for him, it's like a paradox, as he says. Basically, it means that you're favoring. If you have to, in either case, you have to favor one reference over another. But
so it's a choice.
It's a choice, yeah. So that seemed to contradict what he understood of Galileo, where everything's relative the Galileo, the train moving at constant speed is what you call a Galileo frame of reference. So apparently, what I was saying is that phenomena, the idea of a ball dropping, if a train is moving at constant speed, it's almost as if the ball will fall as if the train was at rest. That's what you call the Galileo frame of reference. So basically, all the references, according to Galileo's laws of movement, all the references that move at a constant speed are equivalent. So it's just, everything is just relative. Galileo already had understood that everything is relative. So what he didn't understand is that Einstein, since everything's relative for the mechanical phenomena, why would it not be true for the electromagnetic phenomena? Why would you have two different explanations? Whether, if you consider the framework from the point of view of the coil, or in one case, and in the other case, you consider from the same phenomena from the the viewpoint of the magnet, you don't have the same explanations. So
It's so interesting. You know, it's quite a simple question, isn't it? I mean,
it is.
just
It's like a childlike
it
question.
yes, exactly.
Exactly. So and so that's what sort of got him going on that. So he was saying that there must be something about this idea of absolute rest, which is false, which is wrong. So that was the first step, and the second step was, he says, he writes that in the article itself, in 1905, on the first theory of his first article on theory of relativity. And the second is that he says, like, the light, at the time people thought that light, just like water, if you have a wave on water, you need a medium for the wave to propagate. So if you throw a stone in water, for instance, the wave will propagate on the surface of the water. So they thought, physicists at the time thought that was the same for light. There's some kind of substance in the universe that was invisible, that was called the ether, and that would carry the light, just like water would carry the wave produced by a stone thrown on the lake, on the surface of a lake. And so that was a second big breakthrough. He was only 24 years old. He says, well, and this is enormous, because this is something like, you have to go against the big thinkers of the time, where he says, well, it doesn't make sense that it doesn't make sense that this ether idea doesn't make sense to me, because we were never able to prove that the light follows the laws of the speed addition laws of Galileo, and nothing. He says, until now, nothing has proved that these law of additions apply for light. So therefore, I affirm that ether does not exist, and says, let's envision the fact that ether does not exist, and I'm persuaded that it doesn't exist based on these two experiments, that of the light, and which was the experience of Michelson, that's it, sort of, and so the experience of light and the experience of the magnet and the coil. So, and he does mention the fact that when you travel at the speed of light, it seems counterintuitive, and it doesn't follow the laws of Maxwell, that you would be able to, that, how should I say, that you could basically, you could not travel as fast as light, because if you could, you would contradict the laws of Maxwell. And so it was very intuitive, because there's nothing, how should I say, to really prove that he was right, but he was basically debunking, breaking down sort of the old model of thought, which was sort of, all the physics were based on that model from many centuries, basically, since Newton. So it was like, at 24 years old, it's quite you have to have a lot of guts to sort of like go with your intuition and say, well, I think that is wrong, and maybe we're sort of looking at the problem from the wrong angle. And the problem is amazing. The problem is this idea of absolute space and absolute time. So he sort of decrees that the speed of light, that light is always constant, and that's the key factor. Light will always move at constant speed, whether you're moving or you're not moving. So if you have a flashlight and you flash it, it will still move at 300,000 kilometers per second. But if you're in a spaceship and you're moving halfway the speed of light, and you shoot off a ray of light, the light will still move, that is leaving your ship will still move at a rate of 300,000 kilometers per second. So it will be constant whether you're moving or not moving. And that is key, because if the speed of light remains constant no matter what, it means that time and space need to distort themselves, and that time is relative and space is relative. And that's very complicated to understand from our usual way of in our usual world, because we don't see these phenomena. but
Yeah.
they do exist. So that's what basically Einstein managed to demonstrate, that these equations that already existed, by the way, but on time and relative time, actually you have to take them at face value, basically. And that is that is very important, because Poincaré and other people had already devised the tools that he used, but the main key is a philosophical point, which he was the only one to really address, which is these two questions on the absoluteness of time and space.
Okay, and he was able to do that. He was the only one to able to do that because you say he carefully observed, right?
Yes. So yes, to come back to the magnet and the coil. So it's very important because so he basically looked at this experiment just so that we can understand a bit better, go further in the detail of how he did it. If you have what he imagined is that he said, well, let's imagine I'm a small Lilliputian, a small little. I could, reduce my size in a way, and
Yeah,
I'm
that's
on the
amazing.
magnet. I'm
How
really on the
did he
magnet.
get to think about that? I mean,
That's interesting the way he thought. Yeah, and you're on this magnet, and I'm moving on this magnet. And it's moving slowly, but at a constant speed. What would I see? How would I see the phenomenon? And he said, well, actually, I would see an electrical field in the coil, and that the electrical field would sort of drive the electrons to move, and I would get electric current, and the light bulb at the end of the coil would light up.
yeah.
The two tips of the coil would light up. But he says, well, okay, that's fine. Now let's imagine that I'm on the coil, so I'm at rest with the coil, but now I see the magnet moving slowly. So in the first case, as the magnet moves through the coil, as the there's an alteration of the magnetic field around the coil, right? Because the magnet is moving, so the magnetic field moves, is alterated around the coil. So basically, if that so I'll just move back a step. Sorry, move back a step. I'm on the coil. I'm moving. As I move, I do not see any variation of the magnetic field. That's the first point. I do not see any variation of the magnetic field because I'm on the magnet. I imagine I'm on the magnet again. So, but if I'm on the coil, that's where I wanted to get. If I'm on the coil, as the magnet moves, I will see a variation of the magnetic field, and I will conclude that this variation of the magnetic field produces an electric field, precisely, which induces a current, and which will induce the light bulb to light up. But if I'm on the magnet and I'm moving in the world of the magnet to me will be still, just like Earth is still to us, right? Earth is moving at a constant speed. It's moving quite fast, by the way, but we don't feel it because we're at rest with the moving object, with the moving Earth. So it's the same. If I'm in the world of the magnet, on the magnet, if the magnet moves at a constant speed, to me it will be, it will be like nothing's moving, but and so I won't see any variation of the magnetic field. So if I don't see any variation of the magnetic field, there will be no induced, from my viewpoint, there will be no induced current. So therefore, the light bulb should not light up, according to the explanation.
That's crazy. Totally crazy.
So that was the starting point of this idea of the observation of a phenomena will depend on the in particular electromagnetic phenomena will it doesn't, the idea of an absolute repère, of an absolute frame,
Reference?
frame of reference does not hold, and therefore you have to. That was sort of his first intuition that sort of led him to his first intuition that the way we envisioned electromagnetic phenomena was wrong, and therefore probably the way we envisioned the way light traveled was also wrong. And so that was sort of like his first, and then so he sort of like that was sort of like that those two ideas with him imagine these two experiment, that experiment and the experiment of thought of him traveling at the speed of light, those were the two pillars of his that gave him sort of like the philosophical power to sort of dismiss the old dogma of space and time.
Okay. Yeah. What I love in your book is that you always insert a detailed description of the experience of the experiment for the interested reader, which is great, because if you really want to understand, and because no one had ever explained to me this. I don't think any teacher, professor at school. I'm not a.
Me neither.
I'm a you're a scientist. I mean, you're a scientist much more than I am. I'm a political scientist, but I have never studied that, and no one had ever explained that. And when you read the detailed description that you insert in the book related to each intuition that Einstein had, is quite clear, and you can really understand how he was playing. You say actually it's child's play, right?
Exactly.
So that, that's amazing. Child's play, and also the perspective. You say, I mean, you actually mentioned a quote by Marcel Proust, and you mentioned the solution lies in the perspective, and that the careful observation always produces something. You say careful observation awakens intuition and allows us to glimpse new solutions. Right?
Exactly, and I'm sure that just that single point of using that tool, that conceptual tool, a methodology in life, in management, for instance, in managing people, and the way you deal with also in your, I would say, diplomacy, the way you handle other human beings, and so on, the way you solve problems. That we live in a different world if people actually function that way, which I call la pensée multiperspective. C'est ça. The multi-perspective thinking, which is very, very not taught at school, and
not taught at all.
Not taught at all. Yeah.
No. So this was his first intuition, right?
Yes.
It was this, and then there were two or three more. There were three
so that was
four.
1905. Yeah. So he also wrote other articles, but I don't talk too much about the others, although they are important. Where he the l'effet photoélectrique, the photoelectric effect, which was the same year, which gave him the Nobel Prize many years later.
1921.
He discovered also the atom the same year. So he sort of discovered an experiment by sugar and water, basically, where he sort of explains how using the molecular theory of gases, which is sort of used in a different field, he sort of explains what the Brownian motion is, and this is something that we knew about for many years, but was not explained. There's no explanation, so he explains what the Brownian motion is, and that leads him to sort of like validate the existence of the atom, the atom, which did not until that time. There's no real assurance that the atom really existed. The Greeks had already thought about the atom, but it's in that article of 1905 that we really have the demonstration that the atom exists and what is the basic average size of the atom. So, and then the fourth article, because these are really 4 articles that will change the world in the same year when he's 20, in 1905, in his 20s, mid-20s. The third article is on the famous E is equal to mc squared, which is the relation between energy and mass. That mass is nothing more than energy, very tightly condensed in space.
Yeah. Yeah.
But that's what matter is. So we are all composed of energy, basically, which is very condensed in a very, very small region of space. And that's what energy is. Matter and energy is the same, but matter can deliver a small amount of matter can deliver a great amount of energy, and that's what sort of like where. So that is the famous E is equal to mc square is sort of the basis for nuclear energy, for instance, which lightens cities, but also led to the atomic bomb. So
Yes.
these are main discoveries sort of on the nature of light, the nature of space, the nature of time, and the nature of matter. So this is really big concepts that physicists were grappling with for a long time, and it's quite surprising, that he was able to sort of give some end story to all these questions at the age of 25, 26, so at such a young age. But he did think about these problems for many years, and he was sort of grappling as he used to use what we call thought experiments. Newton used to do it, Galileo used to do it, I believe Descartes used to do it, but he sort of done it in a sort of playful way, like, let's, like a child plays, as you said, let's see what happens if, and
Yes,
so,
exactly.
yeah,
He allowed
yeah,
himself to ask very basic questions and observe. And you do mention in your
yeah,
book that we live in a society where we run all the time and we cannot observe anymore.
yes, that's a big drama I
Hmm.
find of our time. Yes,
It is.
it's very difficult to sort of like step back and just observe, and where we are in the dictatorship of la dictature d'un
Hmm.
instantané, the
Hmm.
dictatorship of the instant. Everything
Yes.
must be done
Yes.
now.
Everything must be done now.
That's
Yes.
right. No time to step back, and so step back and observe, because what I was trying to say in behind that idea is that a lot of difficult problems can only be solved if you take time to step back. That's what Einstein did to sort of come up to these big
Beautiful.
discoveries. It's because he took lots of time, and he would joke about that. So he'd say, "I'm not any smarter than anyone else. It's just that I spend more time on the problem." And
Exactly.
the
If you
question
may
of
allow
time
me
is
to,
important.
yes, if you may allow me to say something about, I mean, it's another field, but I think it's quite related. Meditation. We live in a society today where, the
Mhm.
industry makes you think that you can do a fitness session in 5 minutes, and that will give you the benefits of an hour and a half training. That if you
That's
sit
right.
down, you meditate 5 minutes, it will give you the effect of with a specific meditation of a a very big discovery. That's not true. I mean, you need as a meditator, you need to sit down every day, and you need to sit down, facing silence and facing difficulty and facing the suffering. And there isn't anything that we are. Sorry, my
That's
cats
right.
are fighting.
That's right. Yeah.
There will be nothing else that will give you that insight that this silence and this time you're taking for yourself will provide you. It's really, I think it's another way to wake intuition up.
Absolutely.
Um, so I think we'll take a pause on this one, because I think it's quite important what you just said. And the uh, the problem because you wrote that book in order to help, right, to help people approach life in a different manner. So I think the idea
Yes,
of time
definitely.
and
Yeah.
slowness.
Definitely. Yes. Yes.
Mhm.
And also as I would say, an act of rebellion, because I find I do not I do not agree with
Mhm.
the direction that I would say the world in general, but also the working world, the working forces, everything is sort of like under this dictatorship of you must do things fast, and you go fast, and it's not, and you come to the wrong solution, and people like many years later suffer from a wrong decision that you had to take hastily. But if you had taken more time, you'd come to a Parisian solution, something that would be solid and good for the generations and for the people, for yourself as well, but also for the people around you. So I think that idea of taking time is really important. And the problem is that even in leadership, the leaders don't, because they're under pressure. They can't take the time either. So they don't sort of like, they don't say, well, take the time. This is an important.
Of course
question.
They don't.
Take the time.
They don't take. They actually the leaders,
it's always
and
fast, and that is crazy.
They pay people. They pay people to take time for them. They pay people to be able to have a slow reflection, because they cannot stop. It cannot be stopped. Actually, I don't know if you know that title, but I'm reading a book quite interesting by Jenny Odell, titled "Saving Time."
Yeah.
Very interesting. Very interesting. So
I do believe in every society, modern society, that wants to sort of keep an economic or scientific or technological edge, you need to have people who think, who have the time, who are paid to have the time to think, and to have the time to do things differently, and to have the freedom to do things differently, and to have the time, because that time that you give them you'll have a return which is powerful, puissance 10, and so especially scientists, I believe, a society needs scientists who have that time to come up with these great intuitions that will change the world better, but also
so necessary.
On main problems such as ecology, I forgot the word in English, but all the questions of sustained development, exactly.
Yes,
and those are very complex questions, which you cannot sort of solve them with just by looking with one perspective, because these are problems where it's the social, economic, and also scientific problems, because you need to know science. You need to have scientific knowledge to understand these complex phenomena, and how they all connect. So you need time. And you also need people connecting together their collective intelligence to sort of solve these problems. But I don't see that done anywhere. And that is a big, that is a big, it's unfortunate,
Yes, and unfortunate and quite dangerous. Of course.
And dangerous, yes.
You do mention that when Einstein was feeling that he was onto something important, he felt something in his body, as a yoga and meditation teacher. I really do believe about in the manifestations of the body. And he said that I'm quoting, he was seized by a shudder, an unusual sensory experience, which he would describe in a word difficult to translate, an undescribable feeling of tingling at the tip of his fingers, or Fingerspitzengefühl.
Yes, absolutely. Fingerspitzengefühl. Exactly. But he's not the only one, because you also have other scientists sort of like who express the sensorial experience when an intuition comes.
Oh yes, of course.
Yes, and some will explain that they have like a very powerful sense of the being at the right moment at the right time. There's this other will feel like when you have goosebumps on your on your spine, l'échine dorsale, and so this Fingerspitzengefühl is like, it's a term, a German term, which means like when you have the tip of your fingers is tinkling and you feel that you're really onto something. And he'd often say when he'd have these great intuitions, he'd say, I was not sure, but je le pressentais. Je n'étais pas sûr, mais je pressentais. Je n'étais pas sûr d'avoir raison, mais je pressentais que j'avais raison. I was not sure, but I felt that I was right. I was, that I was onto something. So it's like he had this really, really deep conviction, like this gut feeling that his intuition would open the door to what he was looking for, and it would lead him to sort of des mondes insoupçonnés. Forgot the word in English, but yeah. So
yeah, like mystery word, like dark continents, right?
Yeah, it always brings me back to Alice in the Wonderland. There's a certain scene where she falls. She falls. She falls, and certain scientists get sort of like will tell you that they have this feeling of total freedom where you're like Alice when she falls in the rabbit, and the intuition is sort of like the rabbit, and you fall in this deep hole, and she ends up in a closed, locked up room, and she has different keys she tries, and she knows that when she takes one and she sort of like twinkles, and she finds the right door. And the intuition is a bit that way. It's sort of like it's a very strong sensorial experience, almost like a religious epiphany, and you know you're on. You sort of have this sort of deep conviction that you know you're onto something, and
yes,
Einstein
exactly.
sort of explained it a lot that way.
Well, actually, you do mention Lewis Carroll and Alice Through the Looking Glass when you talk about the third intuition. But do you think, Anthony, could you explain a bit about the second intuition first?
Yeah, and his second intuition concerns the speed of light. So once he knew it was constant, whatever the reference in which you were finding yourself, whether it's moving or at rest, he wondered whether the speed of light could whether it be possible actually to move at the speed of light, or to move even faster than the speed of light. And his conclusion was the following: it is absolutely not possible. Nothing can go faster than the speed of light, or even reach the speed of light, except light itself. And so that is summarized in the famous equation E is equal to mc squared. And why can you not go faster than the speed of light? Well, the answer is quite simple. If you try to go faster than light, well, what will happen is, as you go faster, this equation of E is equal to mc squared, E is the energy, m is the mass. Well, as c squared is a very high number, so as you go fast and faster and faster, imagine you're in a spaceship approaching the speed of light. Well, your spaceship will become heavier and heavier. In other words, your mass will be very, very large. It will be a very, very heavy spaceship, and which means that your inertia increases, and your mass gets very, very big. So what will happen when you reach almost the speed of light, like almost 300,000 kilometers per second, what will happen? Well, your mass will become infinitely large, infinitely big, and the amount of energy required to give that extra little bump to make you go faster than light, well, you would require an infinite amount of energy. So that little amount of energy to go faster than light would become infinite, immensely big. And so all the energy in the universe would not be enough to make you go faster than the speed of light. And that is summarized in his famous equation, E is equal to mc squared. Because if your mass becomes infinite, as you go faster and faster, your energy, the energy required to go even faster, will become even bigger.
All right, so interesting. And now, what about the third intuition? Because you really do make a difference in the book between the first, the second, and third, and I think it's very important to understand that. No one, as I said, had explained that to me before.
And finally, his third intuition has to do with the general relativity theory. So basically, it has to do with gravity. And what he noticed is that gravity is if you want to understand gravity, you can think of gravity as in terms of acceleration. And to come to that conclusion, he envisions a few mind experiments. And one of them is that imagine that you are in an elevator and the elevator is falling very fast. The elevator is totally out of control and then it starts falling. So it's totally submitted to the gravity of planet Earth. And you're in that elevator and you have a few objects, an umbrella, a handful of flowers, a bottle of wine. What would you see? Well, in fact, all the objects would just be floating around you. And at one point, you would not feel your own weight. And so all the objects would seem at rest with respect to you. And you would not feel yourself, you would not feel your own weight anymore. So that was a very, very important observation because it allowed Einstein to understand that gravity and acceleration are the same things. And so he was seeking for this framework of reference where everything would be at rest and would be similar to a Galilean frame of reference. And so basically, the way he solved the problem of gravity was bringing a complex problem, which was that of gravity, to a more simple problem, which is that of acceleration. So he had all the equations that now allowed him to solve for the problem of acceleration. So basically what he did is he connected a complex problem to a problem which is much simpler. And that's what allowed him to finally solve this very complex problem of gravity. And that's something that is everyone can use in their everyday life. When you have a complex problem, just bring it down to something more simpler, a simpler problem, but that is an equivalent simple problem. Just reduce a complex problem to a simpler equivalent problem, and you'll find the solution.
I asked you, Anthony, what musical piece you'd like to listen to, and you did mention Bach. Could you explain why you chose this specific musical piece?
Right. Yeah, sure. Bach, for me, when I first heard Bach, I precisely had that type of experience that I'm talking about, where I remember I was a student. I was in a sort of like a small dark apartment at the time. I was in Angers, and
a French city.
Yeah, it's a French city, and I had my doubts on many things. On my where I wanted to go, because I wasn't sure where I wanted to go, what I wanted to do, and so on. And whether I'd succeed in my studies, whether I was on the right path, and so on. And I played. I think it was this little CD that I found in those little French stores where you can find old books and old CDs, old recordings, and so on. Yeah. And I didn't know this particular piece of Bach, and I played it. And in the midst of all this sort of like moment of darkness and of doubt, is when I first heard sort of like the first 2-3 minutes of the music, I felt enthused, like, and I had this sort of like very strong sensorial moment where I said, "Don't worry," or something, like there's this idea, this. For me, I at the time, I analyzed it as a spiritual or even a religious experience at the time, where I realized that there must have been something greater. There must be something greater. There must be a greater spirit. And for me, when I listened to the music of Bach, they said it's not possible that it was written just by him, but it was written through him. And he was sort of like a messenger who he was sort of the writer, but he was sort of like, how should I say? I sort of viewed it that way, since he was in touch with something greater than him. He also managed to express that greatness. And I sort of said to myself at the time, Dieu existe, there must be a God, But
that's
I
really
would
an
sort of view it
experience you can
differently
feel.
today, but at the time, that's the way I viewed it. But it's the assurance that there is something greater, and this assurance on the moment sort of calmed me of all my worries, and I knew that I could trust in life. It's sort of a strange experience.
So important.
Yeah, and it's like sort of an intuition on life, and this intuition sort of like, it was a very, very powerful sensual and sensorial experience at the same time, mental, spiritual, and sensorial, physical experience, and so to me, that's sort of the way I see the manifestation of an intuition. It may be something that may be as powerful as that, but it may be simply, as certain scientists will say, when they just go on, they just sort of go through their daily life, and they get on the bus, and all of a sudden they just sort of see something. How should I say? They view what's around them in a totally sort of like in a totally different way than they used to, and they feel at the same moment that the sort of when they let their brain loose, when they let go of all the thoughts that they had, and everything just goes sort of how should I say, bright, and the doubt goes away, the questions go away, and then all of a sudden there's this sort of idea that comes, that sort of imposes itself on you, and that's intuition. And Gauss and a few other scientists who also, as well as Poincaré, for instance, they explained. They explain. They don't necessarily call it an intuition. They will say the idea just came to me. I'd been working for days or weeks or sometimes years on it, and I just sort of let it go. And I was just went on to do something else, and bang! It's sort of like in the average day life, something. It comes, and the idea comes, the intuition comes, and when it comes, it's there.
Yeah,
it's
suddenly it gets you.
Sorry?
It gets you.
It gets you, exactly.
Yeah, it gets
right,
you.
yeah.
Okay,
that's right,
what gets you. Yeah, that's wonderful. We're going to listen to Bach, and you chose Toccata and Fugue in D minor, and we're coming back later on. Let's enjoy Bach. Thank you.
Thank you.
In a word, always in a hurry, few people take the time to look closely at things. What this experience of Einstein's shows us is that intuition came to him through the careful observation of the world. Through this attitude, he was able to bring to light what had escaped everyone for almost a century before him. The careful observation of reality allows us to glimpse unsuspected worlds, solutions, and possibilities. It also allows the resolution of managerial and human problems. Careful observation awakens intuition and allows us to glimpse new solutions.
What is for you the use of the theory of general relativity? What's the use today for us?
Well, so the theory of general relativity is sort of the final the most finished work of Einstein, le plus abouti, le travail le plus abouti, and so it sort of describes the behavior of time, of matter in space. So for an example, probably is more speaking, if you were, for instance, to live, if you could, if you're to live, for instance, on a planet which was sort of like much more heavier or denser than our planet, for instance, which was, let's say, a planet would be the size of the planet Earth, but would be like, let's say, 1 or 2 times the size of the sun, for instance, in terms of matter, dense in terms of, right? So if you manage to compress matter as big as the sun, for instance, in the size of planet Earth, for instance, well, if you lived on that planet, time would flow differently. Would flow. Don't know any other word. The best word is flow. Time would flow more slowly.
Flow more slowly.
More slowly. For instance, we know that, like on planet Earth here, compared to time on a satellite, time flows slower because you're submitted to less gravity the higher you go and the further you go from planet Earth. So in space, a satellite, for instance, the time flows more slowly. It's a slight difference, but that slight difference is very important if you want to sort of have a precise GPS, for instance. So the theory of the general theory of relativity for a very practical technological application is very important to have for GPS, because a small fraction of time will lead to a big error. A small error on the time will lead to a big error in space and on the planet Earth. So it will sort of make you wouldn't have GPS that are so precise if you do not sort of have the theory of general relativity. It also plays the first theory of relativity, which is the théorie restreinte, also plays on the time, because a moving object, a satellite, for instance, as it moves, the time flows relative to Earth. Time flows more slowly in the satellite than on Earth. So it's those two time lapse that are taken in account by the theory, the general and the more strict theory of relativity. I mean, Einstein, the general theory of relativity. So they account for those time changes. So those time changes are corrected in the satellites, and that's what allows you to have more precise GPS, for instance. So that's for a more practical example. For more theoretical, I would say, or just fundamental knowledge to better understand the universe, the general theory of relativity allows us to understand the behavior of black holes, for instance. Black holes are, I think most people know, but it's generally a spot, a very condensed star that collapsed on itself, and where you have a very strong gravity pull, and anything that falls in the black hole cannot come out because the gravity is too strong. So understanding how time changes around the those black holes, the time dilatation. There's a huge time dilatation, time expansion, where if you fell in a black hole, for instance, if you still had a consciousness, because you'd be totally destroyed, you'd be pulled into a long spaghetti. But if you managed to maintain the consciousness of time, time would as you arrive closer and closer to I would say the hole, the black hole, you would and you start falling in it, you basically, time would flow infinitely slow compared to someone who was on the outside and sort of really outside of the boundaries of the black hole. So the mass basically has an effect on time. That's very hard to understand. It's kind of counterintuitive, but
Yes.
That's what the general theory of relativity says, is that mass distorts time. So the higher the density of mass in a particular region of space, the slower the time. If you're close to that spot in space where you have a strong density of matter, while your time will flow more slowly. Perhaps people saw the film Interstellar, where you have
amazing. You mentioned that. I was about to say it. I was about to tell you it's my favorite movie.
Right, yeah. And they end up on some planet where 7 years on that planet. Sorry, 1 year on that planet, or I think it was a day or something. Can't remember exactly. But a very short amount of time.
Yeah.
A few days, which corresponded to, I think it was a week, corresponded to 7 years on planet Earth.
Yes, is that correct?
So you see him speaking with his son, and basically he sees his son grow very quickly. Well, sort of every instant where he exchanges with his son is growing fast, because time is.
Yes, it's amazing.
Time is going faster.
I think it was 7 hours per hour, something like that.
That's
7 years. Sorry, 7 years per hour.
Yeah, 7 years per hour. That's right. Yeah.
And is that correct? I mean, is it really
that is correct. Time will flow much slower. You can actually, there's experiments on Earth with accelerated particle, where they accelerate particles, and certain particles they experience this sort of this time dilatation. That's when you move fast. Also, time goes slower. So that's the first theory of relativity, théorie restreinte d'Einstein. But yeah, when it comes, it's mainly mass has two effects. It will expand time, like a clock will go slower. The tick tack between each if you like for a musical instrument, like the metronome, for instance, which the pulse would be slower, basically, if you're on a massive planet. So basically, time 1 second on Earth would be worth it would be worth like a day, for instance, on a massive planet. And you also have the space effect, where the space curves itself around an object. So, for instance, if the Earth turns around the Sun, before, people believed that, according to Newton, that it turned around the Sun because it was submitted to a force, a bit like a kid would spin a ball at the end of a string, and there was an equilibrium between forces, and that's why the Earth turns around the Earth. The Earth turns around the Sun. The Sun being a strong, attractive matter, amount of matter, but according to and even Newton had a hard time believing that. I mean, that was his laws. You said that, but he had a hard time believing that. But what Einstein shows is that it's not submitted to any force. It's just that the space around the Sun, the fact that the Sun is there, curves the space, and planet Earth just moves in a straight line at constant speed, but it just moves in a straight line at constant speed in the curved space. A bit, a bit like when the water swirls around when you empty the sink, the kitchen sink, the water swirls around the hole, which is basically it's not probably not a super good example, but basically when the mass will curve the space, and any object that moves in the vicinity of the object will just follow the curve of the space. And that's why from our viewpoint, we have the impression that the planet is turning around the Earth because it's submitted to the force of the sun, but it's not submitted to any force. In fact, it's just submitted to the curve of the space, the curvature of the space.
Curve of the space.
That's right.
Okay. And why how would you explain that recently, in recent years, everyone is talking about time going quicker?
So that you mean on
people perceive there's no time anymore, that it goes quicker and quicker
on Earth.
On Earth, I mean, very recently, I hear that a lot.
Yes, I think that is because the spinning, it's related to the spinning of the Earth, and the spinning of the Earth sort of like it slightly slows down, or it accelerates, something like that. So if it's if it accelerates, it means the days would be shorter, right? If the spinning, if the Earth spins a bit faster, the days would accelerate. So that's related to the spinning speed of the Earth around its own axis. Yeah.
So that's real. It's not just a perception of you getting old or whatever. It's real.
Well, there's most likely a reality to that, but there's also there may also be a perception of time. As we get older as well, time seems to flow faster, but that is purely perceptual. But
yes,
yeah.
But why is that?
Yeah. So there most likely is. It doesn't seem. Yeah, there most likely is an acceleration of time due to the slight change in the speed of spinning. Yes.
So it literally spins faster.
Yeah.
Okay. And also we're getting old.
Yes. That does have a role on the perception of time as well, because because it's a logarithmic. It's sort of as you get the more you move on the logarithmic curve, the more the more flattened the curve is. So it seems it's a bit too long to explain here, but there is a perception that time flows faster as you get older.
Sure. I mean, basically, since time gets quicker, it's quite useful to know how to trust your intuition to take good decisions, right? I mean, it's a very utilitarian principle, but it's quite important, I think.
Well,
you do mention it's a problem.
Go ahead.
You do mention in your book it's really a very interesting book, and it's quite useful. You mentioned a few things I'd like to go over before we say goodbye for this episode. You mentioned the 2020 rule. You mentioned this rule. What is the 2020 rule?
Yeah, well, the 2020 rule is based on my experience of as a teacher, and also a teaching experience, and also student experience, and research work. Well, it's the idea that you give yourself some time, like the brain attention has a certain amount of time on which your brain is going to be very alert, you're and very efficient. But if you work long hours, because it's something I notice with students, they will sort of like before their exams, they'll do bourrage. They will work hard, non-stop. For instance, several hours, good students, several hours a day, and with nonstop,
Yeah.
and
Terrible.
it's not efficient. It's more efficient to sort of work the same time, but you break the time of work in small sessions in 20 minutes, where you have a 20-minute session of hard work. You have a break of whatever is good for you, but of course not too long, but 10 minutes, and then you do another 20. Or if you can allow yourself 20 minutes work, 20 minutes break, but that's probably abusing. So yeah, a good average is sort of, you work, you study hard for 20 minutes, and then you take a break for 5 minutes, 10 minutes, where you leave your brain wander. You allow yourself
Yes.
to get bored, to allow your brain to
That's what we
wonder,
said. Yeah. Boredom.
and especially don't do anything else than just allowing your brain to sort of wonder, go and see a beautiful, like, look out the window, look at the countryside, but yeah, it's the idea is sort of give your mind a total break, and then you get back into it for another 20 minutes, and so on, and you repeat the operation several times, and what you've learned you'll retain it much better. Why? Because your brain will have the time to sort of recuperate. The brain is a bit like a muscle. If you work on it too much, it will lose its elasticity, if I may say. Like,
Yes, it's plasticity.
it will become plastic. Yeah, that's right. It keeps you keep your elasticity. It's an image, of course, but you keep that elasticity, that extra edge, if you sort of allow your mind to sort of relax. Every time intense, relax, intense, relax, intense session, relax session, intense session, relax session, and so it may change for people. Some people maybe 20 minutes, others maybe 25, but it's sort of an average. And then another 5-10 minutes to sort of to recuperate your mind. And the idea of wondering is very important, because we're in an age where we always think we need to be productive, and that we realize we're not productive as much as because we're organic beings. We're not computers, and our brains don't function like computers, and so
Exactly.
yeah, and we sort of have to keep that in mind, that we're organic creatures, and just like plants, and plants, the same thing. They need sort of that earth itself. If you overuse it, it will sort of you need that time to sort of regenerate. Yeah, the time to regenerate. And the brain needs that time to specific
Very
short
important.
time to
Actually,
regenerate.
the
Right.
industry and all the work structure isn't at all crafted like that. I
No, it
mean,
isn't.
it's the total the contrary. As a teacher, do you apply this principle?
Well, it's very complicated because you cannot do that. Unfortunately, you
Exactly.
can't
How do you
teach
do
20
it?
minutes and say, let's have a break and enjoy the moment of just meditating, not saying anything, or just, but
Yeah.
yeah, so, or have a break, do a phone call, or call a good friend that you enjoy talking to, or whatever. That's what you have to do when you're alone, but you can't do it, of course, when you're. But I do try to at least have a break. If I have 2 hours of teaching, have a break, after 45 minutes or 1 hour, because there's studies c'est avéré. It's shown that the brain attention, when you're following a course or whatever, its maximum is 45 minutes roughly, and then
Yes.
the attention curve goes down. So, and if you have that sort of break, well, the attention comes back. So that's what I try to do. If I have 2 hours straight, I try to sort of like do it. It's easier to do a break, but it's between the 2 hours. But it's easier if you have small groups. But it's more complicated if you have a big amphitheater of 100 students. So only you can't do that, because when they come back, they're too overly excited, and they lose their attention. And so you have to. It works with small groups.
Yes.
And so that's that's also another question, whether it's better to have small groups teaching or bigger groups. But average size groups, 12 or 15, yeah, between 12 and 15 people. 12 people is probably ideal. You can do that. 12, 15 people, you could take a break during
But
the
you know what
teaching
could really
session.
work in that case? I mean, if you, even if your students come back very excited and very accelerated, you could just ask them to sit down, close their eyes, breathing
And
in
meditate.
and breathing out, a few minutes, and
Yeah,
that's it. I
that's
think
right.
what the last part of your book is extremely interesting because you mention the importance of music, nature, all these how to stop, right? These examples
Yes,
of
yes.
how to stop
How
um,
to stop? Yeah,
of the child.
music for me, because the weather
Yes.
is really poor outside. I
Hmm.
live in Normandy, so it's always raining. But yeah, music for me plays a lot. For other people, it may be nature, but yeah, there's this feeling of reconnecting.
Hmm.
There's something bigger than yourself. The
Exactly.
music is that way. Is powerful that way. Nature is
Hmm.
powerful that way. Yeah, and also finding
Meditation.
also the childlike spirit. Why you remember when you're a
Hmm.
child and you enjoyed life.
Exactly.
Yeah,
Exactly. So important. So this last part is really very interesting. You also add at the end several easy puzzles if people want to, to use the several principles you've described to understand and to solve easy puzzles. They're not that easy, but it's really interesting how you solve them. I really would recommend, you know, people to play at the end with the puzzles you offer. Are these
yeah,
puzzles your invention, or have you taken them from? I mean, are they basic puzzles
yeah. Yeah.
in science?
Yeah, the idea was sort of to kindle the childlike spirit in the reader. These are
Mm-hmm.
actually puzzles that are popular puzzles, but you
Mm-hmm.
can't find everywhere. It's sort of more like puzzles that you find in so some of them are taken for as interviews to enter the company Google. Others are puzzles that were asked to Einstein from his friends. Others are general puzzles that were developed by Kahneman, who is
Mm-hmm.
socio I forgot the word in English, but he's
Sociologist,
an yeah.
economist,
Um,
right?
yeah,
Daniel
economist, but
Kahneman.
who studies the behavior of people, a behavior economist, behavioral
Yeah.
economist. Yeah, um, and so, but the idea is to sort of the idea is sort of what I was trying to do in the book was to make a difference between
Mm-hmm.
intuition and bias. What you call the biais cognitif, or
Mm-hmm.
cognitive biases, which is a very I would say wicked enemy of intuition, because it looks
Yeah.
like an intuition, it feels like an intuition, but it's not an intuition. I mean,
Mm-hmm.
it may feel like an intuition, but it's not. So that's why that's the other part which is important when you talk about intuitions, is to double check. What I
Mm-hmm.
mean is to go to the end of your intuition. Don't just stop at intuition. Double check and confront the intuition with reality, or for scientists with the data. For everyday life, it will be confronted. You confronted with the facts. And so, like Einstein used to say, and it's really important. Like a prejudiced or a received idea is harder to break than the nucleus of an atom. And
Mm-hmm.
so it's really important to confront your your what you this particular cognitive bias to to the reality, and
Yeah.
to verify whether it's an intuition, if it's just know whether it's an intuition or not, a real intuition or not. And so that's the first point. The second point is cognitive biases are something that are very well spread in humanity as human beings, and that's as Kahneman explained it,
Mm-hmm.
it's due to our evolutionary process. There's because there's moments when a danger appears. It used to be true when we used to live directly in the nature, a close link with the nature. When there's an imminent danger, your mind must analyze very rapidly the situation, so it doesn't you don't go through the usual analytical process because you don't have the time to do so. So you must analyze the situation really rapidly and therefore take a rapid decision. And in doing so, you actually sometimes you will make the right decision, but most of the time it will lead you into the wrong direction. And so these little puzzles were meant to show that they're all meant. Most of these puzzles are counterintuitive in the sense where it will show you that it will seem evident, the answer will seem obvious to you, but then the answer will show you that you were wrong. So that was sort of the point of that. And the theory of relativity was the same. It was counterintuitive to most people, even to Einstein. But the difference, Einstein knew it was an intuition, but he went, how did he know? It's because he went all the way through the intuitions and he sort of verified. He did something. you don't act, you sort of verify. You go into, you push the thinking further, and you confront the idea of the intuition with reality, with the facts. And when you do that, that's when you'll know whether you have a real intuition or whether it's just a cognitive bias. And that was the point basically of the last chapter of the book, where you have all these tests sort of like make you think and make you question whether about and better understand what this cognitive bias is all about.
It's so interesting to listen to you talking about Daniel Kahneman and how actually he's paper, I think he wrote with a younger colleague of him, right? Amos Tversky,
That's right. Who
I think
unfortunately passed away, but he did get the Nobel Prize for his work. One of the examples is it's one of the well-known examples is that about how a context will sort of make you will induce in you a certain behavior without you knowing. The mentalists use that a lot. So, and they also use that in manipulation for selling you products, for instance, for electing or also for electing a prime minister. So on. There is some kind of I'm not even speaking about also the manipulation through the social networks, but
of course,
but you may sort of like it's what you call the situational bias, where if you're put in a certain situation, you'll react totally differently to a problem that is given to you than if you weren't in that situation. So that's what the contextual bias. One of the most childlike biases that are used as jokes, and it's at school is the idea of the whiteness of milk. If you're what's this, if you say what is this color of the clouds, it's white. What is the if you don't know the riddle, you fall into it. And what is the color of milk? What is the color of sky? White. What is the color of this paper here? White. What does the cow drink? And most people will answer milk, because you induce them into a. So that's just a silly example. That's not in my book, but there's it's just sort of illustrate.
It is in your book. It is in your book.
Oh.
It is.
Okay.
It is. I quite remember it. Yes, it's amazing.
It's a long time I wrote
it's
that
really.
book,
Yes, it's really interesting. It is when you talk about the. I mean, you explain quite thoroughly Daniel Kahneman's discovery and the heuristics, right?
The
There's
heuristics,
several
yes,
heuristics.
that's right. Where many people are, that is important. There's also the bias of conviction. You're convicted. Conviction. This is different. No, in French, it's a different word. Of self
Yes,
assurance. You're self assured. That is the most terrible,
it is.
cognitive bias. You're so sure,
Mm.
but when you're so wrong, the one of this the one example of this is that you'll always collect information that will fulfill your preconceived idea of something without going really exploring all the angles of the question, and so therefore you stay and you reinforce your bias and you reinforce
Yes,
your wrong understanding of the
reality proves
problem.
you. Yeah,
Yeah, that's right.
proves
I think that's the
what
most
you're looking
dangerous
for.
one. Yes, whether it's in research or in life, but or for humanity, and yeah. So that's the idea of these riddles, to sort of like for the reader to sort of question himself on his own. So to sort of like that you understand that we're very fragile with respect to these things, and we have to be very vigilant with respect to this bias problem. And it's like
Yes.
an everyday struggle. You have to sort of like, you can do it in a fun way, but that's the idea. It's sort of like be vigilant, remain vigilant, curious, humoristic, which Einstein was, and playful, uh, but remain vigilant, and that's the idea. And so it's
So important.
as a
Yes.
professor, you're always sort of fighting. Now it's even more true. You're fighting false truths or false information, or and the idea is to sort of always seek the truth, no matter what. I think that's very
Always second
important.
truth. Yeah.
At least it's very important to me. But
Yes.
also in teaching as well, and when
In life.
you study as well in life,
In life, in making decisions.
right,
Wonderful. Well, I think your book is a really great work. It really
that's it.
provides the reader with food for thought, and it's quite clear. It's very clear and very generous in the way you explain actually quite difficult concepts. So I would really recommend everyone to read your book, and I'm sure we will have more interaction on this theme, which is intuition, and it's quite an important. It's a friend. Intuition is a friend.
Right, right.
Trusting the intuition, taking into account what you explained about the biases and the heuristics is quite good. It's not only a book that tells us the intuition is important. It tells us why it is important. It tells us the story of Einstein, and it tells us the dangers and the limits, and we need to take into account with the heuristics and the biases.
Exactly. Right.
So thank you very much,
Well, thank you, Melanie.
Anthony. It was a very amazing exchange, amazing interaction today. I asked you what other pieces, musical pieces, since we spoke about music several times today, and you did mention several pieces. There was first of all a Leonard Cohen piece. Maybe you can tell us why you chose this one.
Oh, Dance Me to the End of Time.
Mm-hmm.
I think it's. That's a good question. I was expecting the other. That piece. Yeah. Well, it's also it's. Well, the main idea of that song is it's about love, basically, and
it's about love.
it's about
Yes.
love and how love stays and remains strong with time, even if
yes. Do you
the
remember?
appearances and the physical envelope changes. This love remains, and this.
Actually,
so that's why
I'm thinking about Interstellar again. You did mention we mentioned the film. Do you remember one of the main quote by Dr. Amelia Brand in the film.
No, I don't actually.
She says, "Love is the one thing we are capable of perceiving that transcends dimensions of time and space."
That's right. That's exactly right. And
So,
that's
yeah,
right, yeah. And that makes the link with the song, exactly, yeah.
it makes a link with the song and also with what we've spoken of today, what we've talked about today, right?
Yeah,
Time and
exactly,
space and
exactly.
intuition.
Right.
So we can leave it here, and that at
Okay.
the end, I still want to insert the other musical piece which you were expecting me
Okay.
to ask you about, which I think it's quite of the dimension of this podcast, the surprise and the authenticity. You wanted us to listen to Nick Cave, and you wanted to. It's quite of a it's a message of hope, isn't it?
No
We're
obligation.
talking about children.
The first, yeah, the Dance Between Live Time. The other one, Nicolas Cage, is because I singer I like very much, but it's also the music's the words are. I don't comprehend all the words because sometimes Nick Cave is very metaphorical, but the feeling I get from
Yes.
that song is that despite, it mentions the gulag and and the atrocities of mankind, and Einstein lived in a period where it was the case where you had these two big totalitarian regimes, Stalin and the Nazi regime, Hitler regime, and he's also Einstein was as a Jew, he was and as a scientist, he was sa tête était mise à prix. He was sort of like a main enemy to the system, mainly also because he was a free thinker. So he was sort of like he was targeted. He had to leave Germany to not end up in the hands of the Gestapo. So
Yeah, like Freud.
basically, that's right. That's why he moved to the States, and he also helped many people in the States. That's also the human side of it. It's very important to Einstein. Like, he also helped. Many people don't know that, but he helped the cause of the legal rights movement. He was a free thinker. He wasn't afraid to sort of. He had the courage to sort of live up to his beliefs, and he was also targeted by the FBI. Edgar Hoover, who considered him as a public enemy number one because of his stances, his political and militant stances with respect to the freedom rights and the black cause, which he spoke up racial segregation in the States at the time in which he lived, where he spoke out openly about it, where he said, I will not, the racism is a disease in this country, and I do not intend to hold my silence on the subject. So he also helped a lot of people who were fleeing from the totalitarian regime in Europe. He helped them to come to evade themselves and to the States. So, and at the same time, he was always carefree and, how should I say, that's light-spirited, humoristic on life, joyful, playful, and of course he had his periods of despair like most people. But what I'm saying is there's always that undertone, that sort of joyful, childlike undertone, and his vision, a sort of positive vision, in fact, of life, and which is quite surprising in considering what he had to face and what he had to see going on in his time. And for me,
very, very surprising.
That's right, yeah. And for me, the song of Nick Cave sort of gives that feeling. There is sort of in time and throughout humanity, there is these forces of totalitarianism or destruction or cruelty, simple, pure cruelty in the world, the gulag. He mentions it in the song, which I call, it's the gulag, basically, the pure cruelty. And it's a metaphorical image, but that's it. And then at the same time, you have the overtone of the children singing in the background. And so for me, that is sort of, it sort of reminds me of Einstein, but it also, because of what I just said, but it also, it's also for me a way of living, because I think it's the only way to sort of have the energy to be able to fight against what is not right. If you have joyfulness, so you have to keep that joyfulness and that childlikeness to be able to be efficient and strong, and also just to be able to give life meaning to life, and that's you have to keep that lightness. And
this is so important. This is what Master Zen teacher Thich Nhat Hanh, whom I love, who passed away a few years ago, says. I mean, we meditate in order to keep our joyfulness up. And in the song, in the Nick Cave song, Nick Cave says, "Oh, children, lift up your voice, your voice, children, rejoice."
That's right.
Thank you so much, Professor Anthony Duncan, for this beautiful conversation. Let's talk soon. Enjoy your evening.
With pleasure. Thank you. Bye-bye.
Thank you. See you soon. Bye-bye.
Bye-bye.
Think outside the box, cross-thematic approach. It is in trying to reconcile two words, that of mechanics and electromagnetism, considered in his time as totally disjointed, hermetic, and irreconcilable with each other, that Einstein discovered a new reality that reconciled and merged these two fields into one, the world of relativity. Indeed, Einstein, rather a generalist in the sense that he had several fields and areas of interest, not only in the physical sciences, was constantly trying to see and make cross-thematic links between his different subjects and knowledge. He always tried to decompartmentalize these different fields. He was particularly interested in mechanics, science of movement, light and electromagnetism, philosophy, sociology, economics, arts, music, the list is long. It is this multifaceted interest and knowledge in multiple fields that allowed him to create new ones and see connections previously undetectable to many of his fellow citizens. Thus, his passion for many subjects was essential to his creativity and intuition. Einstein called his interactional thinking outside the simple sphere of his specialty, thinking alongside. As far as we are concerned, we would say, think outside the box. Inventing is thinking on the side, he said. Nos detenemos aquí por ahora. Muchas gracias por tu escucha. Ahora el podcast Just in Time es una sola temporada. Se han integrado todos los episodios y se especifica con cada episodio qué tema es, qué serie. Serie felicidad para las meditaciones, serie cultura, literatura, cine, reflexión. Esto es cada vez en función del tema. Hay una serie que se va llenando. Muchas gracias por tu escucha y tus participaciones. Recuerdas que puedes mandar mensajes vocales en la página del podcast para que se puedan integrar en los episodios que siguen. Gracias por tu apoyo. Buen día, buenas noches.